The unit that we just started is a unit about square roots and triangles, which I mentioned to you earlier, and I told you that by the end of the unit you're going to see what the connection between those two things is. We've talked a little bit about square roots. Before we start talking about triangles and how they're connected, we need to do a little bit of review of some basic information about working with triangles, because that's going to be helpful to remember if we're going to be using triangles in this unit, which we are. So the next couple of days we're going to be spending reviewing some basic triangle vocabulary and some basic triangle calculations that are going to come in handy as we go through the unit. So today we're going to go through and we're going to review some basic triangle vocabulary and ways you can classify triangles. So first of all, we're going to zip through some basic things about angles, because that's going to come into play if you're classifying triangles. Triangle literally means three angles. So classifying triangles has to do with looking at the angles. It helps us to remember what the different types of angles are if we're going to classify a triangle. So really quickly, we're going to zip through 4 basic types of angles that you should know the vocabulary for. We're going to review it just in case it's been a while since you've heard it or used it, just to make sure that everybody is on the same page. So one type of angle is a 90-degree angle. And if an angle is exactly 90 degrees, we call that a right angle. So that is going to come into play with some of our triangle classifications. So that's a good reminder. When we talk about right angles, we're talking about a 90-degree angle. Other angles we can classify compared to a right angle. So if I take the angle and I make it smaller, so an angle that measures less than 90 degrees, now it's not a right angle anymore because I made it smaller. Now it's an acute angle. So acute angles are angles that are smaller than 90 degrees. Now if I do the opposite, if I take my right angle and I make it bigger, I make it more than 90 degrees. Again, it's not a right angle anymore because I just made it bigger. If I make it more than 90 degrees, now I have an obtuse angle. So just as a reminder, a right angle is going to look something like this, and a right angle will always have a right angle symbol, which looks like a little box in the middle of the angle there. So an acute angle is if I take that and I make it smaller, so that's smaller than 90 degrees, or if I take it and I make it bigger, that's obtuse, more than 90 degrees. Now, if I make my angle really big and I take my angle and I make my angle lie flat, so there's the vertex or the middle of my angle. If I completely flatten my angle out, that is a 180-degree angle, and that is called a straight angle, which makes sense because when you flatten it out, it makes it look like a straight line, even though it's actually an angle, which is where the straight angle name comes from. So those are your basic angle vocabulary that you should be aware of. So you should know right angle, acute angle, obtuse angle, and straight angle. Now, how do we use these to classify triangles? And what are the different ways we can classify triangles? All triangles can be classified 2 different ways. So all triangles can be classified based on their angles, which we were just talking about, and on their sides. Since we were just talking about different types of angles, we're going to start by talking about how can you classify triangles based off of those angles. So there are 3 ways that you can classify a triangle. And we're actually going to start with the description, and then we'll talk about the name and what it looks like. So if I have a triangle with all angles, so remember all angles would be all 3 angles because a triangle has 3 angles. All the angles are acute. So that means all of the angles are less than 90 degrees because that's what acute means. Then that is called an acute triangle because it's all acute angles. So an acute triangle, it would look something like this. So all of those angles are all less than 90 degrees. I could take one of my angles and I could make a right angle in my triangle. Then it would look like this. That is called a right triangle because it has a right angle in it. Now the thing with the right triangle is it can only have one right angle, and then the other 2 angles have to be acute angles. If you think about it, I'm going to draw this to show you, but then I'm going to erase it. So if I put my right angle, so if I try and put another right angle in here, that's not going to work. My triangle won't close. It won't be a closed shape, and a triangle has to be a closed shape. So same thing if I try and put an obtuse angle in here next to right angle, well, I'm sending that off the wrong way. Again, my triangle won't close. So if I put a right angle as one of my angles in a triangle, the only way to close off the triangle is to make the other two angles be acute angles. So that is implied with the right triangle. So a right triangle is a triangle with one right angle, and then it's understood that the other two angles have to be acute angles, otherwise the triangle won't close. It won't be a closed shape. So by definition, a right triangle has one right angle. But we know that that forces the other remaining angles to be acute. So remaining angles are acute. So I could take this right triangle and I could open it up even more, and I could turn that right angle, that was poorly drawn side, but you get the idea, into an obtuse angle. So now I've got a big obtuse angle here. So if I put one obtuse angle in my triangle, now it's called an obtuse triangle because it has an obtuse angle in it. So you can see, we'll finish our thought on the description in just a second. You can see why we took a minute to review right angle, acute angle, obtuse angle, and straight angle, because we're using those as one way to classify triangles. So it's important to know what an acute angle is and what an obtuse angle is. So back to our obtuse triangle for a minute. So this obtuse triangle, in order to close this off, it's going to work kind of like the right triangle. The other two angles are going to have to be acute angles. Otherwise, the triangle won't close. It won't be a closed shape. So it's kind of the same deal as what I was showing you with the right triangle a minute ago. So if we put an obtuse angle in there, the remaining angles have to be acute angles. Otherwise, you won't have a closed shape. So again, remaining angles are acute. So when we say right triangle or obtuse triangle, we're not saying all the angles are right angles or all the angles are obtuse angles. It's just one right angle, just one obtuse angle. Acute, all three angles are acute. So that's one way that you can classify triangles, is by looking at the angles. Now, a minute ago, we said that all triangles be classified based on their angles, but they can also be classified based on their sides. So the next thing we're going to look at is, well, if I'm looking at the sides instead of the angles, what are the different ways that I can classify a triangle that way? Because all triangles have two different classifications. So the different ways you can classify based off of sides has to do with the lengths of the sides. So this is probably one of the most classic triangles that you will see. And it is a triangle where all three sides are the same length. I'm going to use some geometry vocabulary with you because it's good to introduce it. All three sides are congruent. So congruent is basically the fancy geometry word for things that, for shapes or pieces of shapes that are the same size, the same length, the same degree measure. So we don't say equal because we reserve equal for when we're talking about numbers that are the same. When we're talking about objects like angles, side lengths, things like that, then we say congruent, but it's kind of like equal. So congruent means they're the same size. So all three sides are congruent, which basically means they're the same. So we also have a way to show that. So we have a notation for this when things are congruent or the same. Sometimes you will see what looks like little tick marks across the sides of a shape. So those are congruent marks. So those marks, if you have that same mark, any sides that have those matching marks, that tells you that those sides are all the same length. So when you have three sides the same length, they should be labeled on the triangle like that. And this type of triangle, based off of all three sides being the same length, is an equilateral triangle. And the side, or the name literally describes what's going on, because equi means equal and lat means side. So equilateral literally means equal sides if you break down the stems or the roots in the word. Another type of triangle we could have is one that looks something like this. And there are different variations of this, but this will give you the idea. Now I'm going to use congruent marks. I'm going to make it different just for fun. I'm going to put 2 tick marks. Doesn't matter how many tick marks you put as long as they match. I'm going to put 2 tick marks over here as well. So both of those sides have 2 tick marks, which means both of those sides are the same length. So it doesn't matter how many tick marks you use as long as they match. So the nice thing about that is you might have 2 sides that are the same length and 2 other sides that are also the same length, but a different length than the first pair of sides. So you can have lots of different congruent marks in a diagram. So in this triangle, we don't have all 3 sides congruent, but now we have 2 sides congruent. You have 2 sides congruent. That is an isosceles triangle. This is kind of a fun fact, speaking of like stems or root meanings of words. A lot of people don't know this, but it's actually helpful to know in math. But iso is actually a stem that means 2. So we can have all 3 sides the same. We can have 2 of the 3 sides the same. The last one that we could have is if we have all 3 sides different lengths. So maybe we might have something like this. We've got a short side, a medium side, and then a longer side. So this one, all sides are different lengths. So if all the sides are different lengths, then we end up with a scalene triangle. These classifications are most likely classifications that you've heard before and worked with before, but I know that a lot of times with things like this, when you haven't used it in a while, it's really easy to forget it or have a hard time remembering which one was which. So a lot of you guys are probably thinking, oh yeah, I've heard isosceles, I've heard scalene, but you have to know which one's which and be able to tell them apart, which is why reviewing it is a good thing. So those are the 3 different ways you can classify based off the sides. So a final thought on this is to actually look at a couple of quick problems together. So all triangles have 2 classifications. So any triangle, you can give a side length classification and you can give it an angle classification. So just to show you what I mean by that, we're going to look at a couple of different triangles. And this says classify based off of sides and angles. So both of these triangles, we can give 2 different classifications. So if we are classifying based off of the sides, so this first triangle, we could see tick marks, which means 2 sides are congruent. And we just said 2 sides congruent is an isosceles triangle. So if we classified that based off of sides, it would be isosceles. This bottom triangle, if we want to classify it based off of sides, it does not have any congruent marks or any measurement marks or anything labeled on the triangle that would give us proof of these sides being the same length. So without any proof, we can't make assumptions. We can't eyeball it. So in geometry, you always need to rely on what's labeled because things are not always drawn to scale. So without any marks on here or any, lengths of sides labeled that we could look at, we have to assume that all of those sides are different lengths. So if they're all different lengths, that makes this a scalene triangle. So those are the side length classifications, but we can also classify based off of angles. So if we're looking at the angles, this first triangle, I see a right angle mark right there. And we talked about the fact that when you have a right angle, that means it is a right triangle. So this first triangle is both isosceles and right. And you could say it in either order. So some people would say it's an isosceles right triangle. Some people would say it's a right isosceles triangle. It doesn't really matter. Just know that both of those labels apply to this triangle, one based off of sides and one based off of angles. Now, this triangle, we can use a little bit of visual reasoning with the angles because we can very obviously see an obtuse angle down here in the corner. I mean, so a right angle would be coming up about like this. This angle is very obviously bigger than 90 degrees. So you can use a little bit of visual reasoning with the angles if you have something that's very obviously obtuse or very obviously acute. So we have a very obviously obtuse angle, so that means that this must be an obtuse triangle. So this is a scalene obtuse triangle, or you could say it the other way around, an obtuse scalene triangle. So all triangles have two classifications, so hopefully that helps you to see kind of how to use those. So what you're going to do for your assignment today, just to practice your vocabulary a little bit and get it in your head and make sure you're comfortable with it, is you are going to do a little bit of practice with classifying triangles, and also just quickly check in with your angle vocabulary and make sure that you're remembering that and that you have all of your vocabulary straight before we move on and talk more about triangles in our unit. So your notes at this point should match my notes. They should be fully complete, and if they are, then you can move on and try today.